Welcome back, everyone. So in this lesson, we're going to talk about solving rational equations. This is going to serve as an extension to the rational functions and attributes and characteristics and everything that we've already done thus far. So in your homework, that's going to have more advanced or more higher level questions that pertaining to what we've already done. But in terms of this video, we're just going to solve the rational equations and just kind of extend some further knowledge. So just to start off, I'm actually going to start with this basic little adding fractions problem. So I'm actually going to treat this exactly how I would when we're adding, subtracting rationals and in order to solve them. So first off, what I'm going to do is when you're adding these fractions, you have to get a common denominator. So the number in the bottom must be the same. So what I'm going to do is you're going to have to find your least common multiple between these two denominator values. So between 3 and 2, my denominator value is going to be 6. So what I'm going to do is I'm going to take 4/3, and in order to get a denominator of 6, I'm going to multiply by 2/2. So when I multiply by this 2/2, I'm multiplying by a form of 1. That way I'm not changing the number itself, I'm changing the form. So for the next value, for this 5/2, now I'm going to add 5/2. And then in order to get a denominator of 6 here, I need to multiply by 3/3. Now, once again, if I were to simplify this value, we just get another form of 1. So I'm not changing the value, we're changing the way it looks. So when you get here, now I'm ready to multiply these fractions. So I'm going to multiply across. So numerator to numerator, denominator to denominator. So when you multiply, so 4/3 times 2/2 is going to give me 8/6. And I'm still going to add that second fraction. So over here, 5/2 times 3/3 is going to give me 15/6. And now that I have a common denominator, now I can add the numerators together. So it's a fancy way of saying we're going to combine like terms in the numerator. So 8 plus 15, which is going to give me 23/6. So we're going to use this same idea when we're solving these rational equations. So looking at this very first one, what I'm going to do is first I want to look for any vertical asymptotes, holes, or any discontinuities when it comes to rationals. So that's where you're going to set your denominator values of each of these values equal to 0. So in this case, I'm going to have a vertical asymptote at 0. So I know that if I were to get an x value of 0 as my solution, I know that that value technically can't work because it's not defined at 0. So now I'm going to focus on getting a common denominator. So between x and x squared, I need to get the left side denominators to match. The right side, if it's on the other side of the equal sign, technically doesn't matter. But everything on the same side of the equal sign, it needs to match. So 4/x, I need to get a common denominator of x squared. So I'm going to multiply by x/x. And then leave everything else the same. So when I get here, I'm going to multiply it out. So we're going to get 4x/x squared minus 1/x squared. And that's going to equal 3/x squared. So now that I have a common denominator, well, rather, let's focus on the left side first. Now that I have a common denominator on the left side, now I can combine these values. So I'm going to have 4x minus 1 in the numerator, and that's going to be all over x squared, and that's going to equal 3/x squared. So when you get here, now I want to eliminate the denominator on both sides entirely. So I'm going to multiply by whatever's in the denominator. So in this case, when I multiply, the left side is going to simplify, and then the right side is going to simplify. So all we're left with is going to be the numerator. So I'm going to have 4x minus 1 equal to 3, and then we're going to solve this equation. So add 1 on both sides, so we get 4x equals 4, and then divide by 4 on both sides, and we get an x value of 1. So when you get to the very end, what you're going to also need to do is you need to check for extraneous solutions. So when I say check for extraneous solutions, I'm going to take any answers I get at the bottom and I need to plug it back into the original equation to see if it actually works. So my original equation here, I'm going to have 4/1 minus 1/1 equals 3/1 squared, which is just 1. So this is going to be 4 minus 1 equals 3. So that is a true statement. So my answer down here, it really does work. So that is a solution. So now with number 2. So same idea, we need to get a common denominator on the left side where we have multiple terms. The right side over here, we just have one singular rational, so I don't need to worry about getting a common denominator. So on the left side, so I have an x minus 10, and then I have an x minus 2. So whenever we get a case like this, then I need to have an x minus 2 times x minus 2 on the left rational, and then I need to multiply by an x minus 10 over an x minus 10 on the right rational. That's how I'm going to get a common denominator in this case. So when you're multiplying, so 2 over x minus 10, and then I'm going to multiply by my funky form of 1, which on the left rational, we're going to multiply by x minus 2 over x minus 2. So remember, this is still multiplying by 1, so I'm not changing the value, I'm changing the form. And then I'm going to subtract. I'm going to leave my second rational here, leave it alone. But my funky form of 1 I'm going to multiply by. We're going to multiply by x minus 10 over x minus 10. And once again, when I multiply by this, that's still a funky form of 1. And then that's going to equal whatever I have on the right side, which in this case, I'm going to go ahead and factor this. So factors of 20 that multiply to 20, of course, they're factors, and then they add to negative 12. So those factors would be x minus 10 and x minus 2, which, as a little coinky-dink, is what we have over here. So now over here, now I have a common denominator on the left side, so I'm going to start combining. So I'm going to rewrite as 2 parentheses x minus 2, which is my numerator from up here, and then I'm going to subtract this portion over here. So minus 3 parentheses x minus 10, and then that's going to be all over x minus 10 times x minus 2. And then that's going to be equal to 6 over x minus 10 parentheses x minus 2. So when you get here, now I'm going to multiply both sides by my denominator value, so x minus 10 times x minus 2. And then what's going to happen is these factors on the denominator on both sides are going to simplify. So we're just going to be left with the numerator. So I'm going to have 2 parentheses x minus 2 minus 3 parentheses x minus 10, and then that's going to equal 6. So I'm going to distribute, so 2x minus 4 minus 3x plus 30, and that's going to equal positive 6. So I'm going to combine like terms, so 2x minus 3x is going to give me a negative x, negative 4 and positive 30 is going to give me plus 26, and that's going to equal positive 6. I'm going to subtract the 26 on both sides, so negative x is equal to a negative 20. Multiply or divide by a negative 1 on both sides, and we get x is equal to a positive 20. So the next thing I want to do is now I need to check for any discontinuities in my rationals, and then I also need to check for any extraneous solutions. So when I look at my values up here, well, rather the whole thing, but in this case, the right side rational is going to be the same discontinuities as the left side. So I'm going to have vertical asymptotes at 2 and 10, which is when the bottom equals 0. I don't have to worry about any holes, so I don't have to worry about those. Now I'm going to take my value of 20. I need to plug it in. Now this will be fun. So 2 over 20 minus 10, and then minus, 3 over 20 minus 2. And then that's going to be equal to 6 over 20 minus 10 and 20 minus 2. So this is going to be 2 over 10 minus 3 over 18. And then that's going to be equal to 6 over 10 times 18. So this is going to be the same as 1/5 minus 1/6 is equal to, I'm going to simplify this, this is going to be 1 over 3. So that's going to be 1 over 30. Okay, now I need to combine these. So this is going to turn into factors of least common multiple of 5 and 6, which is going to be 30. So I'm going to have 6 over 30 minus 5 over 30, which is equal to 1 over 30, which that is true, which what that tells me is 20, it truly does work. Okay, number 3. So in this case, now I need to get another common denominator over here with my x value. So my x value, when it's a standalone like this, it's going to be written as x over 1. So with this, I'm going to have x plus 4 all over x plus x over 1. So I'm going to go ahead and just write it over 1 just to give me a little bit more visual. And then I need a common denominator of an x value. So I'm going to multiply by a funky form of 1, which is going to be x over x in this case, which once again, that's my funky form of 1. I'm not changing the value, I'm changing the form. And that's going to equal 6. So when I multiply it out, so we're going to get x plus 4 over x plus x squared over x, and that's going to equal 6. And then in this case, I'm going to go ahead and combine. So x plus 4 plus x squared all over x is going to equal 6. In this case, I'm going to multiply both sides by x, so I can eliminate that denominator. Now it's going to eliminate only on the left side, but we're just going to move it to the right side. So I'm going to go ahead and rewrite my numerator here in descending order. So that's going to be x squared plus x plus 4, and that's going to equal 6x. Okay, and then I'm going to subtract it over. So that's going to leave me with x squared minus 5x plus 4, and that's going to equal 0. And then when you get here, now that you have a trinomial, I'm going to factor. So I want factors of positive 4 that are going to add to negative 5. So that's going to give me x minus 1 and x minus 4, which is going to equal to 0. So then when I set each of these individual factors equal to 0, we're going to get 1 and 4. So those would be my solutions for this one. But of course, once again, I need to go back and check for discontinuities and then check for extraneous solutions. So in this case, when I look at my rational over here, the only vertical asymptote I see that I'm going to have would be at x equals 0. But now I need to plug in my solutions and see if either of these would be extraneous. So if I were to plug in 1, so that'd be 1 plus 4, which would be 5 over 1 plus 1, which is going to equal 6, which in this case, that's 5 plus 1 equals 6. So that one's true. So 1, it works. But now I need to check 4. So if I check 4, so 4 plus 4 over 4 plus 4, and we want to see if that's going to equal 6. So 4 plus 4, which is 8 over 4 plus 4 equals 6. So that would be 2 plus 4 equals 6, which is true. So they both work. So in this case, come on, there we go. So in this case, that one also works as well. So we have 2 solutions in this case. Okay, I'm actually going to skip number 4. It's the same scenario, but I actually do want to do number 5. So with number 5, so now we're looking at 3 denominator values. So I guess one way you technically could do this, if you didn't want to deal with 3 rationals and you have it set equal to 0, you could move this term over here. That way you only have to do with 2 rationals on the same side, but it's really up to you. I'm going to go ahead and tackle it as if it was 3. So in this case, I have denominator values of x, x plus 2, and then x squared plus 2x. So if I were to factor this x squared plus 2x, this would be x and x plus 2, which those factors are both accounted for in my others. So what that means is I'm only going to have to manipulate and maneuver my first 2 rationals. I can leave my third one alone. So I have x minus 1, and that's going to be over x. And then my funky form of 1 in this case, to get a common denominator, I'm going to multiply by x plus 2 over x plus 2. And then add 3 over x plus 2. And then this one, I'm going to multiply by x over x, which now I'm going to add that third rational, but it's already got both of the factors accounted for, so I don't need to multiply this third one by anything. So when I rewrite, so I'm going to have x minus 1, parentheses, x plus 2, and that's going to be over x, plus, this is going to be 3x over x, whoops, over here I forgot my x plus 2, there we go. Then x parentheses, x plus 2, and then plus 6 over x parentheses x plus 2. And that's going to equal 0. So now that we have a common denominator amongst all the terms, I'm going to combine all the numerators. So x minus 1 parentheses x plus 2. We're going to multiply those binomials in the next step. Then plus 3x plus 6. And then that's going to be all over our denominator, which is x parentheses x plus 2. And that's going to equal 0. So now I'm going to multiply x times x plus 2 on both sides. So I'm going to get rid of this denominator. So on the left side, it's going to simplify. And then anything on the right side over here, we have it times 0. So this whole thing is just going to go back to 0. So I'm going to go ahead and multiply these binomials out. So that's going to give us x squared plus x minus 2 plus 3x plus 6. And that's going to equal 0 on the right side since all of this is just multiplied to 0. Now I want to combine like terms, so I'm going to combine my x values, and then I'm going to combine my constants. So we're going to have x squared plus 4x plus 4, and that's going to equal 0. So when I factor, we're going to get x plus 2 times x plus 2, which I can rewrite as x plus 2 squared equals 0. And then when you get here, I'm going to take the square root of both sides, so I will get x plus 2 equals plus or minus the square root of 0. Now, if you were to get another value other than 0 here, you would need to double check both solutions. So you could potentially get two solutions here. So that's just going to be x plus 2, which is going to equal 0. So I get an x value of negative 2. So now that I have my solution, I'm going to go ahead and double check up here, check for any discontinuities. So when I look at my vertical asymptotes, I'm going to have a vertical asymptote at x equals negative 2, but also 0. So if you notice, that negative 2 is what we got down here. So the math says it works, but in reality it doesn't because of the discontinuities. So what this tells me is x equals negative 2 is extraneous. So this would be extraneous, which means the one and only solution we have doesn't work, which means this would be no solution. Now, one thing I do want to cover that I think a lot of people get mixed up on is just because we have an extraneous solution, 1 or 2, doesn't mean that there is no solution. So for example, let me insert hypothetical rational. Okay, and then let's say our discontinuities, let's say we get discontinuities at like -1 and 2. So blah, 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 blah. You solve it, you solve it, you solve it. And then you get x values of, let's say, -1, 3, and 5. Okay, so if I were to plug it in, well, I see that -1 right here is a vertical asymptote, so I know that one can't work. So just this solution alone so far, this would be extraneous. However, my other solutions, I still have x equals 3 and 5. So those would still be solutions. So it doesn't mean that it's no solution. It just means that one particular solution, quote unquote solution, it just means that one particular value doesn't work. So you do still need to check the other ones. So of course you do still need to plug in the 3 and the 5 into your hypothetical rational and see which one works, because this one may be a vertical asymptote, and then, for example, 3 may be extraneous and not work when you plug it in, but then the 5 may work. So then that means your 3 may also be extraneous. So in this case, it may only be 5. So there's a few different layers that you're going to have to check, but hopefully it's not too bad. So I would definitely recommend doing 4 and 6 on your own. With number 4, I will say you should get an x value of -3/7. And then I'll let you plug it in, and I want you to check to see if it works. And then for number 6, we should get x values of -8 and -3. Now, once again, I'm going to let you plug them in, and I want you to check to see if they actually work. So, bon voyage.